porter governor. Right? This is the next type. So here is a schematic of a porter governor. Okay, so you can see this is a kind of modified form of a word governor. Right? Why I'm saying it? Because in the word governor the sleeve does not have a weight. Right? But in the porter governor the sleeve will also have some weight. Right? So that's the difference between what and porter governor. So you see the diagram, right? Almost similar to that of the word governor, right? P is the pivot of the arms, right? There are two arms, and there's a ball B, right? Two balls B, okay? And there's a sleeve, right? This is a sleeve, central load, right? So this sleeve have some weight, right? That is central load W. So this will be considered as capital W, and the weight of the balls will be considered as small w for the sake of doing numerical, right? Okay. And also there are few additional terms here. Okay, now we are taking into account the angles also. The alpha is the angle between the arm and the vertical shaft. The upper arm. Okay, I'll consider it upper arm. And beta is the angle between the lower arm, or we can consider it sleeve. This is actually arm. This is sleeve, right? And the vertical shaft, right? So these are two additional terms, right? Alpha and beta, they are two additional terms from the word governor. Okay, so T1 is the tension on the arm, and T2 is the tension on the link. Okay, and also we have the weight for the ball, which is small w, and the weight for the sleeve, or we can consider it as central load, that is capital W, right? And the height of the governor, that is between the ball's center and the pivot point, that is H. Okay, and the force which is acting on the ball, that is Fc, centrifugal force, right? And we consider this central load weight as W by 2. Why? Because we are taking the half of the governor to solve it, right? We are not taking the complete diagram to solve it. So the weight would be W by 2 for this side, and if you consider this side, that would be another W by 2, right? And that's why it's mentioned as W by 2, right? So we'll see the terms M, mass of each ball in kilogram, right? So M would be mass of each ball in kilogram. Small w, weight of each ball in newtons, right? Small w would be mg. And then you have capital W, capital M, mass of the central load in kilogram, right? So central load, the mass is M, and capital W, weight of central load in newtons, that is capital Mg, right? So this is W, capital Mg. Then R, radius of rotation in meters, right? So this R is the radius of rotation. The radius it is between the center of the ball and the shaft, the horizontal distance between the center of the ball and the shaft. H, height of the governor in meters, right? So that's again vertical distance between center of the ball and the pivot point. Okay. N, speed of the balls in RPM, right? N is the speed of the ball, and therefore omega is equal to 2 pi n by 60 angular speed, right? Fc, that is centrifugal force which is acting on the ball, that's equal to mr omega square. Okay, and T1 force in arms Newton, T2 force in the link. Okay, so this is arm, this is link. Alpha, angle of inclination of the arm or upper link to the vertical, right? So to the vertical, the angle of inclination is alpha. Angle of inclination of the link to the vertical, right? So lower link to the vertical, this angle is beta, right? So these are the terms which we are going to use to find this equilibrium of this portal governor. Okay, so we'll solve it, right? So now we have to find the forces. Okay, so there can be two types to solve this portal governor, right? First one is the method of resolution of forces, right? The second one is instantaneous method that we'll study later. Okay, not later, at the next step, right? First we'll go through the method of resolution of forces, right? So now we are going to resolve the forces for this weight and this mass. Okay, considering equilibrium of the forces acting at D, right? So D, that is weight, the sleeve weight or central load you can consider, right? So that is the weight at D. So we are going to consider the equilibrium of this D. So what are the forces acting on this D? First is the weight of it, that is W by 2. Okay, and second is the tension, T2, right? So these are the only two forces acting on D, right? So we'll resolve it. W by 2 vertically downwards will be equal to T2 cos beta, right? With the angle T2 cos beta. So T2 cos beta is equal to W by 2, which is mg by 2, right? So from this we can find T2 is equal to, right? T2 is equal to mg upon 2 cos beta, right? Mg upon 2 cos beta. So now we have found the T2 or tension in the link. Okay, lower link. Now we are going to resolve forces for this mass, that is the ball, right? We are going to resolve the forces for this mass. So we'll see how many forces acting on this ball and by the action of how many forces which is in equilibrium. As you can see, we can find four forces. First one T1, which is acting this way. T2, this is acting this way. Weight, this is acting downwards, and centrifugal force, which is acting horizontally outwards. So this mass B is in equilibrium based on the action of four forces, right? So now resolve it by taking vertical and horizontal components of forces, right? So first we'll see the vertical component. Okay, T1 cos alpha, right? T1 cos alpha is equal to T2 cos beta plus W, right? So we know if there is alpha, this is also alpha, right? So T1 cos alpha acting upwards, right? T1 cos alpha is acting upwards equal to T2 cos beta, right? So if there is beta, this is also beta. Okay, T2 cos beta, which is acting downwards, and the weight of the ball, right? That is W. We can consider it as small mg by mg, right? So that is also acting downwards, right? Small W. Okay. So these are the only three forces which are acting on vertical direction because Fc is horizontal, so on vertical component it is 0, right? So based on the action of these three forces, this ball B is in vertical equilibrium, right? So when you solve it, instead of T2, we can replace it with mg upon 2 cos beta, right? So T2 can be replaced as capital Mg upon 2 cos beta. So if I put T2 capital Mg upon 2 cos beta, that cos beta and this cos beta will be cancelled out. So what we will be having is capital Mg upon 2, right? Capital Mg upon 2 plus W, we know that is mg, so that is small mg. So T1 cos alpha is equal to capital Mg by 2 plus small mg. We consider it as equation 2. Okay. Now we are going to resolve forces in horizontal direction. This is vertical direction. Now we are going to resolve it in horizontal direction, right? So to horizontal direction, to this way, Fc is acting, right? Fc is acting that way. T1 sine alpha plus T2 sine beta are acting this way, right? So they two are acting this way. Okay, T1 sine alpha is acting this way and T2 sine beta is acting this way, right? So when we resolve it, we will have T1 sine alpha plus T2 sine beta is equal to Fc, right? T1 sine alpha plus T2 sine beta is equal to Fc. Since weight is acting vertically downwards, it will not affect this horizontal equation, right? So again, we will replace this T2 with capital Mg upon 2 cos beta, right? So instead of this T2, I will put capital Mg upon 2 cos beta, right? So T1 sine alpha plus capital Mg upon 2 cos beta into this sine beta is equal to Fc, right? So we know sine beta upon cos beta is equal to tan beta, right? So Mg by 2 tan beta plus T1 sin alpha is equal to Fc, right? When we further resolve it, okay, T1 sin alpha equal to Fc, right? Fc minus mg by 2 tan beta, right? Fc minus mg by 2 tan beta, right? We'll consider this as equation number 3. Why we are doing it? Because we want to find T1, which is an unknown term. So therefore, we want to make T1 is a separate term, right? If it is being here, that's it, T1 sin alpha plus mg by 2 tan beta, right? So we already know about beta. So we don't need to worry about it. Now we are trying to isolate T1 so that we can find the T1. So T1 sin alpha is equal to Fc minus capital Mg by 2 tan beta. Okay. Dividing equation 3 by equation 2. So equation 3 we have found T1 sin alpha is equal to Fc minus capital Mg by 2 tan beta. Equation 2 we have seen T2 cos beta plus W is equal to capital Mg by 2 plus Mg, right? So now we are going to divide one by one. So T1 sin alpha upon T1 cos alpha, right? On one side, T1 sin alpha upon T1 cos alpha is equal to Fc minus capital Mg by 2 tan beta, okay? Fc minus capital Mg by 2 tan beta upon capital Mg by 2 plus small mg, right? Capital Mg by 2 plus small mg, okay? So we'll solve it, right? So let rest of them is mathematical, right? So capital Mg by 2 plus mg, right? Capital Mg by 2 plus mg into tan alpha, because T1 and T1 will be cancelled out. Sin alpha by cos alpha is equal to tan alpha, and by cross multiplying it, capital Mg by 2 plus small mg tan alpha equal to Fc minus capital Mg by 2 into tan beta. Fc minus capital Mg by 2 into tan beta. Okay. So now we have tan alpha on one side and tan beta on the other side. Okay. Capital Mg by 2 plus mg equal to Fc upon tan alpha. Now we are dividing the complete equation with tan alpha, right? Why we are doing it? Because we have tan alpha on one side and tan beta on the other side. We are trying to bring them to one side and we are trying to give it a small name or term so that we can solve it, or else we have to take this tan alpha tan beta thing throughout the equation. So in order to reduce the complexity, we'll take them to one side and we'll give a certain term for it to reduce the complexity. So we'll see mg by 2 by plus mg, so capital Mg by 2 plus small mg equal to, we are dividing it with tan alpha both the sides. So here tan alpha will be cancelled out. Here Fc upon tan alpha, okay, minus capital Mg by 2 tan beta upon tan alpha, right? Substituting tan beta by tan alpha is equal to q, right? So why we do this? We need to substitute this tan beta by tan alpha by q, or else what we have to do? We have to carry this tan beta tan alpha thing throughout the equations. Okay. So in order to reduce the complexity, we did this. Tan beta by tan alpha we consider now as q, right? So instead of this, we will write q for now, and later at the end part, we will replace it with tan beta upon tan alpha if necessary. Okay. And tan alpha is equal to r upon h. So we can see here, this is alpha, right? This is alpha, this is r, this length is r, this length is h. So tan alpha can be written as opposite r upon adjacent h, right? So tan alpha can be written as r upon h. Okay. So now tan alpha can be written as r upon h, and tan beta by tan alpha is considered as q. Okay. Okay. Now we'll rewrite this equation again. So capital Mg by 2 plus mg equal, instead of Fc, I can write mr omega squared, right? Fc is equal to mr omega squared. So that is mr omega squared upon tan alpha, right? So that is 1 upon tan alpha. We see tan alpha is equal to r upon h. So 1 upon tan alpha is h upon r, right? So mr omega squared into h upon r minus, right, minus mg by 2, right? Mg by 2 into tan beta upon tan alpha. I told you it is considered as q, right? So that is q. right? So let's solve it. M omega squared into h, right? M omega squared into h. Why this r and this r will be cancelled out? So m omega squared into h equal, right? Small mg, right? Small mg we have here plus capital Mg by 2, right? And we are taking this capital Mg by 2 also that side, right? So that we can bring it into brackets, right? So if I take this one here, that will be plus. So capital Mg by 2 into q, right? So capital Mg by 2 into q, right? So when you expand this one, you will obtain this, right? Mh omega squared, that's here. Mh omega squared. Mg is here. Mg by 2 is here. Mg by 2 into q, that's here, right? So in order to bring this bracket and mg by 2 to one side, we are taking this mg by 2 here, okay? From this we can find the h, right? Why h is on other one side and rest of them on the other side. So h is equal to small mg plus capital Mg by 2 into 1 plus q upon m omega squared, right? So mg plus capital Mg by 2 into 1 plus q upon m omega squared, right? So 1 upon m omega squared. This can further be reduced into this m omega squared. If we take inside, this m and this m will be cancelled out. So what will happen is m, okay, m plus mg by 2, right? Mg by 2 into 1 plus q, right? This 1 plus q into g upon omega squared, right? So what we are doing is we are taking out the g and we are sending in the m, okay? So g is taken out. So this g and this g will be taken out. So that is this g, okay? This omega squared, it's already there. We send this m inside, so this m will go inside and cancel this m. So what okay, that m is here, right? So we are sending m here but taking omega outside, right? So if we solve it, we will have mg, that's here mg, okay, mg plus mg by 2 into 1, that is mg by 2 into 1 into mg by 2 into q, mg by 2 into q upon m omega squared, right? Upon m omega squared. So we didn't do anything, we just rearranged it, right? That's it, we have done. So therefore omega squared, now we are trying to make omega squared as the subject. Here h is the subject. Now we are trying to make omega squared as the subject, right? So this area you don't need to do actually. If the question is to find h, you can stop somewhere here. If the question is to find omega squared, you need this, right? So depending on what is your subject, you can move. So this is all the, I mean from here it's already over, right? So now we are trying to rearrange it, right? So omega squared is equal to, right? If I make omega squared as a subject, small mg upon capital Mg by 2 1 plus q into 1 upon mh. So this omega squared is moving there and that h is coming here, right? That's it. So if I rearrange it, m plus m by 2 1 plus q upon m into g upon h, right? So this omega squared moved there and that h came here. Similar thing here, right? This h go there and omega squared came here. Instead of omega, right, we know we can replace it with 2 pi n by 60, right? Omega we know we can replace it by 2 pi n by 60. So I am replacing this omega with 2 pi n by 60 and rest will keep it as it is. So 2 pi n by 60 whole square is equal to small m plus capital M by 2 into 1 plus q upon small m into g by h, right? So we know 2 is a numerical term, pi is a numerical term, 60 is a numerical term. If we replace them all, what we'll have is capital M plus, sorry, small m plus capital M by 2 1 plus q upon m, right? This term into g by h, this term with this 2 pi by 60, right? With this 2 pi by 60, I am dividing it, so that is 60 by 2 pi whole square, right? So when you solve it, what you will have is small m plus capital M by 2 1 plus q, right? Capital M by 2 1 plus q upon m into 895 upon h, right? So this 60 squared upon 2 pi, if you solve it, you will have 895. So 16 60 3600, 2 pi whole thing squared, that is 4 into pi squared, right? So you will, if you solve it, you will have 895, right? So now the subject is n. N squared is equal to small m plus capital M by 2 into 1 plus q upon m into 895 upon h, right? So as you can see here the subject is capital N, here the subject is omega, here the subject is h, right? So after this point, right, after this point, it's only the rearrangement, right? So substituting and obtaining the values are almost done here, right? So if the question is about h, you will go for this. If the question is about omega, you will go for here. If the question is about n, you can go with this equation, right? Now, so here again, this g is taken as 9.81. Okay, g is taken as 9.81. So now we'll see certain facts or norms here. When the length of arms are equal to the length of links, right? So this is arm and this is link. So if the length of this and if the length of this are equal, and the point P and D lie on the same vertical line, right? And if this P and D lie on same vertical line, right? So here they are small offset, but in case if they lie on same vertical line, okay, you can see if this and this are same, and this is lying on the same vertical point, this distance is a common length that is also same, then what will happen? This alpha and beta will be equal, right? So if these conditions are fulfilled, if this length and if this length are equal, if this point and if this point are equal, I mean on same shaft, then you will have tan alpha and tan beta as equal, right? So if tan alpha is equal to tan beta, then Q we are already seen tan alpha by tan beta, right? The previous page we have seen Q is equal to tan beta by tan alpha, right? So if tan alpha and tan beta are equal, what will be happening? Tan beta by tan beta, which will be 1, right? So if tan alpha is equal to tan beta, then Q will be equal to 1, right? So instead of this Q, we can put 1 if these conditions are fulfilled, okay? And therefore, this equation 4 will become n squared is equal to, right? This n squared is equal to m, small m, plus capital M. This 2 and this 2 will be cancelled out. Why this 2? This Q is 1. We have already 1 plus 1, 2. That 2 and this 2 will be cancelled out. So m plus m upon small m into 895 upon h, right? So that equation will take this modified form if Q is equal to 1, okay? When the loaded sleeve moves up and down the spindle, the frictional force acts on it in a direction opposite to that of the motion of the sleeve. Right? If the question asks you to consider the frictional force also, right? So we know if the sleeve is moving upward, the frictional force will be acting downwards. If the sleeve is moving downward, the frictional force will be acting upwards, right? So under such conditions, along with this capital Mg by 2, right? Along with this capital Mg by 2, we also have to add a frictional force. Right? That could be plus or minus F, right? So if it is acting along the way of movement, that is plus. If not, that is minus, right? So in that case, this n squared will take the modified form. N squared is equal to mg plus, okay, mg plus mg by 2 plus or minus F. So this F is the frictional force F. Mg by 2 plus F plus or minus F into 1 plus Q, right, upon mg, right, upon mg into 895 upon h, right, into 895 upon h. So when you solve it, that is equal to mg plus capital Mg plus or minus F upon mg by, when this Q is 1, right? So there is friction also acting, right? And also this condition is true. In such case, this will take a form like this. So when this condition is true, that is when these two arms are equal and these points are on same shaft, this would be satisfied, that is Q is equal to 1. So if q is equal to 1 in this case, right, q is equal to 1, so 1 plus 1 is 2, that 2 and this 2 will be cancelled out, right? So under such condition, and when the friction is acting, what will be happening? Mg plus capital Mg plus or minus F upon Mg into 895 upon H, right? So the format will be changed as this if the friction is acting plus the Q is 1, right? The plus sign is used when the sleeve move upwards or the governor speed increases, and the negative sign is used when the sleeve move downwards or the governor speed decreases, right? So based on the direction of friction, either we will add it or subtract it from the equation, right? So this is the first method of solving such kind of equation, that is method of resolution of forces. Why it is called as resolution of forces? We resolve the forces here for this mass, central mass, or central load, and we resolve the forces for this ball, right? And we eventually ended up in final solution, right? So that's why it is called as solving by resolution of forces, right? And we have another method also, right? That method is instantaneous center method, right? Instantaneous center method. We have already studied the instantaneous center while we are dealing with the velocity diagram, acceleration diagram. So now we have to find just the instantaneous center, and rest is the same, right? So in this method, equilibrium of the forces acting on the link BD, right? Link BD are considered. The instantaneous center I, right? So here is the instantaneous center I, right? How do we obtain this? By extending this line PB and extending this line D, and they will meet at point eventually, and that point is considered as the instantaneous center for now, right? Lies at the point of intersection of PB, right? Intersection of PB produced and a line through D perpendicular to the spindle axis, right? So PB extended here and the line through PD perpendicularly to the axis of spindle as shown in this figure, right? So now this is the instantaneous center. Why do we do this? In order to take the moment about any of the points. So we take this instantaneous center point to take moments, right? So previous case, we just resolved the forces. We didn't go for the moment, but here we are going to do it with the help of moments, right? Taking moments. So if I take this this instantaneous point, right? So this is the instantaneous point, and based on this point, we are going to take the moments, right? So I'll take a clockwise rotation, okay, on this point, right? On this point, we'll take a clockwise moment. So if you take, right, FC is opposing it, right? So it is on the other side of the equal sign. FC into BM, right? So the length between the action of FC to the instantaneous center is BM. So this length, okay, this length equal to W. W we can see it is acting along the force. So that is W, small w into the length IM, right? W into length IM. Plus we have another force that is capital W, right? So capital W by 2, that is also acting along the clockwise direction, right? So this is acting anti-clockwise direction, and these two are acting clockwise direction. So capital W by 2 into the length ID, right? The length ID, okay? So instead of W, we will replace it with the M now, right? So that is equal to small m, that is small w, we can replace with small mg into IM plus W, capital W, we can replace capital MG by 2 into ID, right? So FC is equal to mg into, I am dividing the complete equation with BM, right? So this is BM, okay? So I'm dividing the equation with BM. So mg into IM upon BM plus mg by 2 into id upon bm. Okay, mg into im upon bm plus capital mg by 2 into id. This id can be written as im plus md, right? Im plus md. So im plus md upon bm, right? So mg, small mg into im upon bm plus capital mg by 2 into, so we'll take it into single, right? So im upon bm, md upon bm. Okay, im upon bm, md upon bm, right? So why do we do this? In order to bring in angle tan alpha, right? So im upon bm, we can see im upon bm, we can consider it as tan alpha, right? Opposite im upon adjacent bm can be considered as tan alpha, right? So im upon bm, that is tan alpha. Then md upon bm, md upon bm can be considered as tan beta, right? md opposite upon bm adjacent, that is tan beta, right? So md upon bm is tan beta, and we have mg by 2. Again, im upon bm, im upon bm, that is tan alpha, right? So mg im upon bm can be replaced with tan alpha, right? So mg tan alpha plus capital mg by 2 into tan alpha plus tan beta is equal to fc, right? So im upon bm is equal to tan alpha and md upon bm is equal to tan beta, right? Dividing throughout by tan alpha, right? So now we have tan alpha here and tan alpha plus tan beta here. We are going to divide the complete equation with tan alpha, right? So if I divide it with tan alpha, fc upon tan alpha equal to mg tan alpha divided by tan alpha. So tan alpha and tan alpha will be cancelled out. We will have mg, right? So that is mg plus mg by 2 into 1 plus, right? We divide this term with tan alpha. So mg by 2 into tan alpha upon tan alpha 1, tan beta upon tan alpha, that is tan beta upon tan alpha. So mg by 2 into 1 plus tan beta upon tan alpha, right? Okay, so that is 1 plus q. Why 1 plus q? We already see that q is equal to tan beta by tan alpha. So we assume, right, q is equal to tan beta by tan alpha. You can take any other letter a or b or c, anything, right? So we have now small mg plus capital mg by 2 into 1 plus tan beta upon tan alpha can be considered as q, right? So if you remember, so this is the same equation what we have obtained while we are resolving it in the force method, right? We know that Fc is equal to mr omega square. So centrifugal force, which is mr omega square, and tan alpha is equal to r upon h, right? From the diagram, you can see tan alpha is equal to r opposite upon h adjacent, right? So that is r upon h. So now we are going to replace this Fc and tan alpha. Okay, so Fc can be replaced as mr omega squared, right? So mr omega squared into 1 upon tan alpha. This is 1 upon tan alpha. So if tan alpha is equal to r upon h, 1 upon tan alpha is equal to h upon r, right? Opposite of that, h upon r equal to this side mg plus capital Mg by 2 into 1 plus tan beta by tan alpha is equal to q, right? 1 plus q. This r and this r will be cancelled out. So what will be having? H omega squared m, right? And we will be taking h as the subject. So h is equal to, we will take this m omega squared this side, right? We will take this m omega squared this side. So mg plus capital Mg by 2 into 1 plus q upon m omega squared, that is m omega squared, right? So it is equal to small mg plus capital Mg by 2 into 1 plus q upon m omega squared. So that is equal to m plus capital M by 2 into 1 plus q into g into m omega squared, right? So I am taking this g and this g to here, this location, right? So m plus capital M by 2 into 1 plus q g upon omega squared, right? So this is just an arrangement. Okay, so this, if you see this equation, this is the same equation what we have seen while we are discussing with the other method, right? You see here m plus capital M by 2 into 1 plus Q upon M into G upon omega square, right? So same thing here, M plus capital M by 2 into 1 plus Q upon M into G upon omega square. So the rest of the condition would be same here. If tan alpha is equal to tan beta, this Q will be 1, right? So if this Q is 1, then we will be having H is equal to M plus capital M upon small m into G upon omega square, right? Why this Q means 1 mean 1 plus 1 is 2, this 2 and this 2 will be cancelled out, so we will be having small m plus capital M by M into G upon omega square, right? So this is the condition if tan alpha is equal to tan beta. So if tan alpha should be equal to tan beta, then we should have this length and this length to be equal, and also this P and this D should be on the same shaft, right? So this is how we formulate the formula to find the H or omega square or whatever is asked about the photogovernor.